Hey everyone, welcome to another episode of GOTO Unscripted. We're in Copenhagen at GOTO Copenhagen 2023. I'm Andrea. I'm from Italy. I'm a member of the Elixir team. Elixir is a functional language that runs on the Erlang virtual machine. And I'm here with Francesco.
So I'm Francesco. I'm founder and technical director at Erlang Solutions, O'Reilly Offer. Been working with the Erlang ecosystem since the mid-90s. We're very fortunate to have seen a programming language become an ecosystem of languages. And I think it's probably what we're going to talk about today, right?
I think so, yeah. So Francesco and I live very close to each other. We've never met in Italy, only through conferences, various conferences. He's been involved with Erlang a lot longer than I have. I came into the Elixir generation. So how was it to see this ecosystem grow, or like this small language? I guess
it was really interesting. I mean, the first language on the Beam came about. I discovered it had been written. It was called Rhea by Tony Arcieri. And I heard about it at OSCON, the open source conference in Portland in 2008. Mm-hmm. And so when we ran our first conference in America, we invited Tony to come in and present it. Mm-hmm. It was really, really interesting looking at how he'd taken a Ruby-like syntax and then applied it to Erlang, running on the Beam, which is the prevalent virtual machine on which we run everything today. And then from there, soon after, Lisp-flavored Erlang came about with Robert Verdig, mm-hmm. FN, by Mariano Guerra. And so, there were a lot of, Prolog, got ported. So there were a lot of languages which came about. But, and some even being used in production. But we never kind of realized it had become an ecosystem of languages, and probably until 2014. When we were in San Francisco, and we had, for the first time at the Erlang factory, dedicated a whole track to Elixir. Mm-hmm. It was still in the early days. I think it was the year the first Elixir Conf happened. So I think something like 140 people, including Dave Thomas's dog. And I was walking with Garrett Smith, and we were discussing this new phenomenon called Elixir, and really excited about what was happening and how Elixir was opening up the door to whole new communities of programmers. And in that conversation, it kind of transpired. Gary came up. Well, it's Erlang's becoming now an ecosystem of languages. Mm-hmm. And that's when it clicked. Yeah, well, that's exactly what happened with Java. That's exactly what happened with .NET. Mm-hmm. And the same was happening with Erlang, and it's been amazing to see, and you look at it today. I think there are over 35 languages running on the Beam, which is really, really impressive. Mm-hmm. Not all obviously are used in production; many are experimental. Mm-hmm. But
and it's interesting. I was speaking with Sam Aaron from Sonic Pi earlier. Yeah. And he was talking about the differences between Java and Clojure being a lot more than the differences between, for example, Erlang and Elixir. And I think that's, do you feel that's true, that like in the languages on the Beam are much, while there are many flavors of languages on the Beam, and some are statically typed, some are have different flavored syntaxes like Lisp, or they look like Prolog, they look like Lisp, or they look sort of like Ruby. Do you feel like the difference? My feeling is that the differences are like.
I agree. They're not. The differences aren't major, but that's, in my view, is that Erlang, they got a lot of things right when they invented Erlang, when they created Erlang. They spent probably 3 years prototyping a certain domain of problem domain of scalable, fault tolerant. Soft real-time systems. First looking at all existing languages, industrial languages being used in the industry back in the 80s, and then from there using a virtual machine implemented in Prolog. So by the time they started creating the first virtual machine written in C, they'd come so far in this prototyping activities that they'd really streamlined and created a language with the bare bones and bare necessities. You know, if you ask the different co-inventors of Erlang, what they contributed, Mike Williams once told me, I spent most of my time convincing Joe and Robert that even though this was a really cool language feature, we didn't really need it because it didn't add any value. And these design and prototype activities, they looked at different constructs which they tested, and if this construct added value and reduced the code base, then and made the task of building these telecom systems easier, they kept it. If it didn't, they removed it. And so as a result, I think Erlang became a very compact language, which was fit for purpose. And it's and so as a result, I think all the languages written on top of the Beam, get all of those features and then add their own flavors to it. Accidentally look at the T-shirt I got. I put on today. What
Which
flavor?
Of Erlang is your favorite? Yeah, this is very small. I was wondering though. Do you think that these similarities between these languages are also due? At least that's also how I feel in part, but also due to the fact that Erlang is really hard to extend. Like it's not like the basic data structures in Erlang, for example, are very set. Like it's just those. And if you look at things like, for example, queues in Erlang, they're implemented as like on top of existing data structures, tuples and lists, right? Or if you look at structs in Elixir, they have to be implemented on top of maps. They're like something that compile time checked, but they have to be implemented on top of maps. Do you think that's...
I mean, everything is possible, even with Erlang. But, when people go out, when language inventors go out and create a programming language, they're out to solve a particular problem. And I think, so the problems they're trying to solve dictates, the features which they need. I mean, if you look at macros, for example, they exist in Erlang, but they're made with, they're very well hidden and they're not accessible to everyone. So they're very hard to use and implement. And that was a conscious decision because they didn't want the language to be extendable. I think one of the problems they were trying to solve was the cost of maintenance. They were trying to reduce maintenance and operational costs in systems, which they did very, very successfly with the toolings and the hooks, introspection hooks you've got into the VM. But everything we were being able to, all the systems we've been able to solve. It's rare we've gone in and said we wish we had this or that. Maybe libraries might have been missing, but not really language features, because keeping it simple meant you could do things with a few lines of code on top of it if you need it. And that,
a super interesting thing that comes to mind is that maps, for example, are really recent Erlang feature, right? And they now feel like a really necessary language feature, right?
Absolutely. I mean, maps were first presented, I believe, at the Erlang user conference by Richard O'Keefe, and what eventually became maps in 2000, but it probably took a decade before they made it into the language.
Yeah. And because I remember it was around the time Elixir was becoming 1.0 that they actually made it to
correct, yeah,
OTPR like 17 maybe. It's like
correct, correct. And again, this is Ericsson. Ericsson is the benevolent dictator, and that's the realities when you're dealing with open source. And they're incredibly conservative over new features because they add to the language. Because if they add something, they need to support and maintain it. And
for decades.
Yeah, and not only that, but everything they do needs to be backwards compatible. Because there are tens of millions of lines of code in production. You make something which isn't backwards compatible, you break the build, and upgrading will can take years. We've seen, we've worked on projects where they forked the Beam, and to get the code base back on the latest version of the Beam, 3-4 years later, in some cases, it took 6 to 12 months of work, and we've seen this on multiple occasions.
The thing I like though is that I have a wish list of things that would go into Erlang. Obviously, I think maybe the biggest one would be structs, because the interoperability would be really nice. Like the fact
I think structs is exactly what is stopping the ease of calling Elixir libraries from Erlang.
Because you have to do some sort of esoteric looking stuff to get them to work.
Exactly, and it is one of the gating issues. So there are conversations ongoing, and one of them is possibly to add structure to the language for compatibility issues. I mean, I'm going back to the very first ElixirConf. I remember Jose saying, we've got we've got access to all of the libraries, written, in Erlang, which is decades of work of open source libraries, which we can use from Elixir. And, the opposite isn't, you don't have the opposite from Erlang, and it's payback time. So adding structs would be, that would be one of the huge benefits from it.
I think so, yeah. And there is such central, like Elixir seems to have developed around structs a lot. Like it's very idiomatic. You see them all over the place, extremely idiomatic, and it would be really nice to see them in Erlang core, because you could probably significantly optimize tagging the struct, for example, because we have to use this little like underscore struct underscore atom key that takes memory in all the structs that we have in the system, and like it would be nice to have it in the Beam, because that would probably
absolutely.
So that's very interesting.
As a side note, Robert Verding added structs to Lisp flavored Erlang, which is one of the many languages. It's a Lisp implementation running on the Beam. And so that now allows him to call all the Elixir libraries completely seamlessly. So
I'm curious if Gleam has structs. Gleam is a statically typed language that's compiled via Rust, though. Like the Gleam compiler is written in Rust, and it generates Erlang bytecode or AST. I don't actually know, but I wonder if it has structs, and I wonder if it. I would bet that it has like records. It would be interesting to know if they actually can get away with not having them tagged, because it's a statically typed language that you can like probably do the checking.
It's a good point. I don't know that. We'll have to ask either.
But one thing that I've noticed in Erlang that's very exciting is that I do feel like sometimes it can be hard to extend Erlang, the VM itself, which is probably for the best, right? Like it's a very intricate VM with like lots of it's a big VM, right? It's a very smart VM, like with the scheduling and the process and the garbage collection. It has lots of features, and so it would be hard, I think, to make it extensible in any significant way when you go and touch the depth of the VM. But recently, it's been like the releases of OTP have been really exciting. Like they've added a lot of stuff in the last 2 or 3 years. Like Gen State M was there, aliases were there, which are like incredibly awesome. The being able to call Gen servers, I think this is OTP 25 or 26, like very recent, like being able to do asynchronous calls to Gen server and like then check for the response later. All this stuff is like getting into core, and that's awesome, because it allows us to build a lot of these like lower level abstractions ourselves.
Correct, yeah. But
I'm a big fan.
If you look at an actual Beam itself, it's, I think, the biggest challenges in extending and adding things to it is ensuring they don't disrupt the soft real-time properties of the scheduler, which is, I think, their biggest fear.
Yeah, and it's interesting that you mentioned this, because like one of the people that are familiar with the Beam and Elixir probably know and Erlang and Elixir probably know this, but one of the only shared functional data structure, like pure functional data structure lives in shared memories is binaries, right? Like bigger binaries larger than 64 bytes. So they go into like a shared memory area, so that you don't have to move them around processes, you just move references. And that's the only data structure that I know of that's completely shared across. Well, now they have atomics and counters, but
ETS tables is another which has destructive operations.
Right. Yeah. So, but ETS table sort of like meant as a shared memory area, right? But it's treated as an impure. Like you can actually modify its state, right? And instead with binaries, it's not like that. You can't modify the selected binary. And it's so interesting to me that even just binaries, which are very pragmatic to be in a like separate memory space after 64 bytes and all of that, they cause many problems because like it turns out that like a lot of memory leaks in Erlang applications are from parsers copying binaries all over, like taking big binaries and splitting them up, and like exactly, and like creating copies of these like smaller binaries, or having like memory leaks where you have a reference to a binary that you don't clear up, or the process doesn't die, or this or that, and then you have a memory leak because like the binary never gets garbage collected. And it's interesting because you really notice that like even one data structure that is built in still bubbles up to problems for users in some specific use cases, because like it's hard to do this. Like the Beam has wonderful properties of software uptime and per process garbage collection and all this stuff, but they're hard to maintain. Maybe that's,
that's I think you've answered your own question. As to why I think Ericsson has to be very conservative in changes and addition. I mean, just the JIT compiler, which that was at least 3-4 years in the making, extensive research. But when that came out, it allowed WhatsApp to reduce its server needs by around 30%. That was the head of WhatsApp went out and tweeted about it. Thanking Ericsson for it, and that's that in turn translates to huge energy savings, which is something we're seeing.
It's interesting that Elixir itself is not it's now in a spot where we're not adding much to it either, right? Like I think arguably more stuff is coming up into Erlang in the past like couple of years, maybe, because Elixir has been Elixir's ecosystem is expanding incredibly, right? Like all the machine learning stuff is nuts, like the live view stuff is nuts, but
this is the positive. Also, a good part of it is also the positive influence Elixir is having back on Erlang.
Because people are realizing that a lot of things you actually have to solve them in Erlang. Like for example, aliases, process aliases, or counters, or atomics. All these new features that have been added, persistent term. Those are like fantastic features that have been added in just last couple or 2 or 3 years, I think, in Erlang, and you just cannot do them. Like something like persistent term, which is like this shared persistent storage that gets just copied to all processes, very, very fast to read, very painful to write. It's awesome, like for so many use cases, but you just can't do it in, like you have to do it at the VM level, right? You can't do it at the, so it's really awesome that these features are like popping up in Erlang, because like from Elixir, we just get them for free, and from, in Erlang, you can just use them. So like they're really, truly, and you can use them in Gleam, you can use them like in all the runtimes. Like that's the benefit, obviously, of adding features to Erlang. So
that's what amusing. If you say, oh, nothing's happening with Erlang, no, there's a lot of work happening. Ericsson is doing an amazing job.
I think so.
At driving things forward, but it's not so much the language. It's the libraries where the effort is being put in, and on the virtual machine. And
I think that's tricky, because like the work that the Erlang team is putting into Erlang is really low level. Like something like persistent term, or something like atomic, or counters. These are really low level stuff that usually you need. 99% I think of use cases are for like library authors or OTP itself.
Exactly, which
right?
the end user doesn't see.
For example, are mostly used for gen server calls, and like they're used by OTP itself, right? So you don't really get to, and the advancements and the news that are happening in Elixir are like they seem more exciting, because they're like much easier. It's like, oh, there's a new machine learning library that lets you like pick up models from Hugging Face and run your own machine learning models. Like that's something I can touch very easily, and it can really get easily to users. Or new features in live view, they get right in the hands of users. And instead, the work that Erlang is doing is just as important, just as prolific, right? Like they're doing a lot of stuff. It's just that it's so within maybe
it's much more low level. It's a low level
it's
where
harder
you need
to get it to users.
It's where you need to have full control over what's going on.
But it does have an impact. I mean, I've used for libraries, I've used counters, I've used atomics, I've used persistence, all the new features, like, and they've been awesome. So
an amazing new feature, which I actually discovered reading the manual pages a couple of weeks ago, is the ability to do match specifications. So match specifications, a match specification, for those of you who don't know, is a program which provides a set of, it's a term, which consists of a set of variables, a set of logical operations you can do on these variables, and then a set of actions. And so it's a very simple program. It has a very, very small subset of operations and actions you can take. And it was originally being used for tracing local and global function calls in runtime. We're having to trace compile the code, and you wanted to turn on or turn off the trace or trigger trace messages when trigger trace messages when you when certain conditions were met. So only if the first argument to a local call was user Andrea, and and the second argument was had them call home, for example. You could, at that level of granularity, you could trigger a trace message if you knew that was that was where you needed to go in and troubleshoot. And this has been extended to message passing, to pattern matching. It's just been extended to a large variety of things. It also works on ETS tables. It has worked on ETS table for a while, but so basically, they brought the power of tracing of kind of sequential calls, to a lot of other constructs where, again, you receive a process receives a particular message, you trigger, you start tracing, So
it's a very fast way of matching on stuff and extracting information,
exactly,
which is why it's allowed in ETS tables, which are generally
it's not for the faint of heart.
It's
especially
horrible,
if you're doing it in a live system. But
it's quite
it's
intense.
For these really kind of hard to reason, hard to figure out bugs. It's again, one of the points of Erlang was to reduce operational costs, and this is. This really reduces the time it takes to troubleshoot systems. And find that needle in a haystack.
Yeah, I think Elixir is doing I'm not involved with any of it. That's why I allow myself to say it. But it's doing an amazing job at doing something similar with compiler tracing and code diagnostics. There has been a ton of work really in the last year to improve Elixir's Lexer and parser and all the code compilers.
So you're putting hooks into the code basically
everywhere. Yeah. So essentially the language servers become very precise in doing stuff. Now Elixir is able to partially, for example, partially tokenize strings that are of Elixir code that have syntax errors, so that we can point you to the syntax error and where it is, all these tools. And that's really it makes me think of that, because that's really precise tracing at the compilation level, right? And I'm not involved in any of it, sadly, but I will benefit from it.
It reminds me of when they went in and added line numbers in error messages, which
Elixir is able to, especially with this tooling stuff, is able to having its own compiler written mostly in Elixir, right? And a little bit of Erlang. The compiler for Elixir itself is very high level, so it's very easy to. I've always felt it's quite easy to contribute to, so it's quite easy to do bigger stuff compared to language where you have lower level compiler that has to take care of optimizations and do multiple more passes. Elixir's compilation passes are less, for example, right? So you have easier opportunities for doing this sort of stuff, tracing compilation hooks and all this stuff for code diagnostics. So it's very interesting.
Why don't you tell us, Elixir is making its way into a lot of new verticals. I think one of them is machine learning.
Yeah.
Can you share a little bit over what's happening in that space?
Yeah, I think I am not involved in that space at all, so always a pinch of salt. But essentially, we have ported the Elixir. Sean Moriarty in particular has been leading all of this, but the Elixir community has been writing DSLs for Elixir that compile to these GPU frameworks. I don't know any of them. I will embarrass myself, but essentially you can do tensor operations, in Elixir now. Yeah. And from that, was born a whole ecosystem of things that you can do now in Elixir related to machine learning. The really interesting thing to me is that it's not necessarily better than Python, as far as I understand, for example, because they both compile to GPU instructions. Eventually they use these Google compilers for GPU instructions and stuff. So it's not necessarily a better performance, but the thing that's been really interesting is it seems to be one of the first languages to actually challenge Python's dominance over this space, right?
It focuses on user experience and adaptability.
It looks nice.
If they do for machine learning what they've done for web development in Phoenix, where they've really reduced the barrier to entry, where you need to know a subset of Elixir to be productive using Phoenix, and not understand anything of what's happening under the hood. And basically in no time you deploy a website. If they do the same for machine learning, I think it's going to really open up the doors to
there's a lot of focus. Absolutely. There's a lot of focus on user experience again, like we saw with Phoenix, like we saw with LiveView, like all these tools, like we saw with
Nerves as well.
Nerves, exactly.
So Nerves is the embedded framework.
It's a framework for like embedded devices, and like the same thing, like it's very, very usable, very user friendly, and they're doing the same thing with machine learning. And to me, it's very interesting because like you can see that the ergonomics make a big difference, right? Like having, even if like maybe performance not going to be better than Python because they're going to compile to like very similar. I don't know anything. I could be saying like total lies here, but like I think that's how it works. And it turns out that the ergonomics and developer experience and usability matter to developers, right? And I think it's interesting. This is one of the, from my very limited experience, it seems to be one of the very few languages that are actually challenging because Python's like, it's the thing in the machine learning sphere, right? Like that's, you write Python, and instead like Elixir is coming up with like, oh, hey, you can actually write this in Elixir too. And it's very, very interesting to see what that will bring in the future. I have no clue. I'm not involved, sadly, because I don't know. I don't really do anything with machine learning, but
what really kind of excites me is the ability to run everything in the same memory space. So if you look at Phoenix, and you decide to use Mnesia as a backend database, you'd have the web server, you'd have your business logic, and your database all in the same memory space, which make it extremely fast. I mean, it's faster to create dynamic pages and to read static pages cached in Redis. If you can do the same, if the same happens with machine learning, then it's going to be fantastic.
We use a lot of ETS at my job for caching and for like responding very quickly to requests. And we have an endpoint for beaconing BDS stats now that's like doing
ETS tables are the
like
Redis of the Beam.
It really does like half a milliseconds, and it just queues requests, and then we flush them out to.
You want distributed ETS tables? You just use Mnesia. It's
there's a lot of tools, very powerful tools.
So I mean, just to wrap up, I mean, what's your view over kind of the future of Erlang, Elixir, Gleam, and the ecosystem as a whole?
Good question. I have no clue. My dream is just that like they become so interoperable that I can write my libraries in Elixir, some libraries in Gleam, some libraries in Erlang, and they just like all works together. That's my dream, because like I think people are gonna have preferences. Erlang is a simpler language, for example, and I think a bunch of in that it has less features. Strictly speaking, like there's less feature surface, so it's like simpler. Gleam has completely different characteristics, like the statical type stuff, and I would like to be able to choose which one I want to use for different use cases. Like I want to write a compression algorithm. Like maybe Gleam is really nice because it lets me like do it, like have static types that check all this stuff. I need to write something related to like mingling with protocol stuff. It's nice to have like static types. I want to write something that like is going to be complex, and I want to write it in Erlang to keep the feature set simple. I want to write something that's like uses protocols. I want to be able to use Elixir. So my dream would be to have, and also to have a single community. Like I wrote a bunch of drivers in Elixir for example, Cassandra, Redis, like all this stuff. I would love if people from Erlang could just use them, because like the Cassandra one, for example,
absolutely. Like, I think interoperability is key.
Yeah, I hope that's my hope.
I completely agree with you. And and from my point of view, I'm seeing kind of Erlang, Elixir, and other Beam languages making their way to edge networks and even out on IoT devices. And that's, for example, where I think Gleam would really take off for the simple reason it's statically typed, and it makes the language much more secure.
And you can take off a bunch of stuff from runtime, because
you're actually reducing the surface of attack and external surface of attack. But the great thing is that all of these languages are interoperable and and dependent on each other. So hoping they'll thrive and continue growing together. Thanks, Andrea.
Thank you.